let's take a look at concepts of factoring trinomials. This is on factoring a trinomial of the type x squared plus excuse me, bx plus c. All right. So what is a trinomial of that type? Well, I'll give you an example of that. Okay. Suppose we're asked to factor something like this here. Factor x squared plus 7x plus 10, for example. Right. Here is a trinomial of this type. So I have x squared here. You can see matches up, right? What's my b in here? Well, it's going to be 7. Can we see that? My b is 7. What's my c? Well, that's going to be 10. Can we see that? So b is 7, c is 10. So this is a trinomial of this type. All right. Now, before I get into factoring this, though, I'll get back to this problem in a moment here. Let's recall what we did back in 7.3. So let's recall this problem we did. Let's say I want to multiply out two binomials of this type. x plus 5 times x plus 8, for example. All right? Okay, so we FOILed it out, if you remember, right? X times x is x squared. X times 8 is going to be what? 8x. 5 times x will be 5x. And then 5 times 8 is going to be what? 40. Okay? So, therefore, I combine like terms. I get x squared plus 13x, 8x and 5x, 13x, and plus 40. All right? So, what I'm suggesting to you here is this, that look, after I multiply out these two binomials, I get this trinomial, x squared plus 13x plus 40. Well, is this of this type right here? Well, yes, it is, right? Can we see that? My b in this case is 13, and my c is what? 40. Can we see that? So again, b is 13, c is 40. So this is a trinomial of this type. So what that suggests to us also then is the factoring. In other words, if I want to write this trinomial as a product, then that means I'm going to write it as what? A product of two binomials of this type. Do you see that? So two binomials of this type will multiply out to this trinomial. So therefore, this trinomial will factor into two binomials of this type. All right. So and notice something else further though. All right. Let's look at the 5. Let's look at the 5, the 8, and the 13 right here in my answer. All right. Well, observe that what? 5 plus 8 is 13. So observe that 5 plus 8 is 13. In other words, my two numbers right here have to add up to what? To the x term, to the x coefficient. My two numbers here add up to the middle number. Can we see that? And what about 5 and 8 and 40? Let's look at 40 right here. All right? 5, 8, and 40. Well, let's observe that 5 times 8 is 40. All right? So that means what? Not only do my two numbers have to add up to the middle number, it also has to multiply out to the what? Last number. Can we see that? So when we're looking for these two binomials in this factoring problem right here, then I need to find two numbers that will add up to this middle number and multiply to this last number. All right? So let's write that down. So here's what I need in this. So first of all, this is going to factor to the two binomials of this type. So x here and x here. Okay, imagine if I FOIL this out. X times x is what? X squared, right? So I need x here and x here. Can we see that? All right. Now, let's figure out these two numbers right here, these two mystery numbers here. Okay. So what do I need? Well, let's write down the criteria. So need two numbers that multiply. So first, we're going to satisfy the multiplication criteria. So first, these two numbers should multiply out to 40 first in this case, right? So we need two numbers that multiply to what in our example here? To 10, all right? So first look for these two numbers. And also add to what? To the middle number, right? Add to, in this case, add to 13. In this case, we'll add to what? 7. Okay? So I need two numbers that multiply to 10 and also add to what? 7 in this problem here. Well, without too much thinking about it, I think you know the answer already. It's going to be 2 and what? and 5. Because 2 times 5 is 10. 2 plus 5 is what? 7. So 2 and 5 will work. Now you may say, does the order matter? No, it doesn't. I have to put 5 and 2 if I want to. So the order doesn't matter. Okay? But the sign has to be correct. In this case, they're both positive here. But that can change in a little bit when I change the example problem on you. All right? When I change the example on you. Okay, so therefore my two numbers are 2 and 5. So that's it. So the answer is going to be what? X plus 2, X plus 5, right? So these problems aren't too difficult, as you can see, right? So my solution is going to be x plus 2 times x plus 5. That's the factoring of x squared plus 7x plus 10. Right? So these problems can happen very quickly if we can do the mental arithmetic. But I want you to, again, figure out the two numbers first before we write the answer here. Okay? And you can do it in your head if you want to. You don't have to show all this work I'm showing here. All right? Let's go ahead and try another one here. Let me go and clear off the screen. Let's factor this one. Let's factor x squared minus 6x minus 6x minus 7, for example. All right? Let's try this one right here. Okay, so what do I need here? Well, I need two numbers. Again, we're always looking for those two mystery numbers, right? So I need two numbers that multiply this time to what? To the last number, and the last number is what? -7. To -7, so the sign does matter. You have to get the signs right. So I need two numbers that multiply to -7 and add to what? Add to the middle number. Add to, which is what? -6. So the sign does matter here, right? So the middle number is -6. The last number is -7. I need two numbers that multiply to -7 and add to -6. Okay? So what two numbers will fit the bill here? Well, let's see. Well, let's think about this a little bit. Well, the only two numbers that multiply to 7 are what? 1 and 7. All right? That's it, right? There's no other possibilities, right, in terms of the integers, all right? So let's go ahead and figure out the signs then. Now, I want to multiply to -7 here, right? So, for example, if I put a -1 here, -1 times 7, that is -7. But what is -1 plus 7? Well, that adds up to +6. So do I want that? No, I don't. Can we see that? So this is no good. Even though, yes, it multiplies to -7, but it does not add to what? -6. This adds to +6. Well, that's only a small adjustment there, right? So you have to play with the signs a little bit after you so first figure out the combination of numbers, then play with the signs, all right? So I don't want -1 and 7. I want 1 and -7, as you can see, right? Because 1 times -7 is -7, so we're good on that. Excuse me. And 1 plus -7, 1 plus -7 is what? -6. Okay, so we're good on that as well. So these two numbers is what we need in the factory. So once we get these two numbers, we immediately have the solution. So it's going to be what? X plus 1 for the +1 times x minus 7. Since I have -7 here, right? So x plus 1 times x minus 7. Again, if I FOIL this out, if I multiply this out, I'm going to get back to the original. Let me do that for you verbally here, right? X times x is what? X squared, check. 1 times -7, -7, check. What about the middle term, -6? Well, let's check the middle term. This gives me what? This gives me 1x, and that gives me what? That gives me -7x. Can we see that? 7 times x times -7 here. That's -7x. So I do have -6x. Okay, which is the middle term. So therefore, my answer is correct. X plus 1 times x minus 7. Okay, as our solution. Let's try another one. Let's go ahead and factor this one. X squared plus 3x minus 18. All right, x squared plus 3x minus 18. All right, so what do I need here? Well, again, I need two numbers, right, that multiply to. So that multiply to what? -18, the last number, and add to the middle number. Add to +3. So the sign does matter, right? So need two numbers that multiply to -18, the last number, and add to the middle number, 3. So that's all we're looking for these types of problems. Not too bad at all right? I'll extend the concepts in a little bit. Okay, then, so what's going to work out here? Well, let's see. So I'm thinking of 6 and 3, right? So 6 and 3 will give me 18, right, in terms of the product. Now, I want 6 plus 3 to add up to +3. How can I make that happen? Well, the only way that these two numbers can add to positive 3 is going to be what? If the 3 is negative. Can we see that? Now 6 times negative 3, negative 18. Check. 6 plus negative 3, positive 3. Check. So therefore, my solution here, let me put it here since I ran out of space, is going to be what? X plus 6 times x minus what? 3. Okay, so these are very quick problems, I think, on the homework here. So it's not too bad at all. All right, let's go and try another one here. Let's try this one. All right, let's look at x squared plus 13 plus 13x plus 13x minus 40. Okay, let's try x squared plus 13x minus 40. All right, so what do I need here? I need two numbers that multiply to negative 40, the sign counts, all right, the last number, and add to the middle number, 13, all right? Well, like the example I gave you earlier, maybe you're thinking of 5 and 8 then, right? So let's look at 5 and 8, because 5 plus 8 is 13, right? All right? Now, but remember, I want to multiply to negative 40. So I need to satisfy the multiplication criteria first before you satisfy the addition criteria. So find two numbers that multiply to negative 40. Well, 5 and 8, let's say I make 5 negative. So that multiplies to negative 40, right? All right. But how about adding it? Well, if I add that together, that only gives me positive 3. So that's no good. Okay. How about, let's try another combination. How about if I make 5, how about positive 5 and negative 8? That also multiplies to negative 40, but once again, that does not add up to, what, 13. So that's no good. Okay, so these two combinations are no good. Yes, they multiply to negative 40, but they don't add to 13, as you can see, all right? Let's see, let's look at other possibilities, all right? How about 1 and negative 40? Well, again, that multiplies to negative 40, but that does not add up to 13 clearly, so that's no good. And likewise for negative 1 and positive 40. That multiplies to what? To negative 40, but again, does not add up even close to 13, so that's no good either. Okay, so no good, no good, no good, no good, all right? Any other combinations? Well, how about 2 and 20? Let's try that, 2 and 20. Well, 2 and 20, certainly I can get negative 40 out of it, but again, playing with these signs is not going to give me, what, 13 at all, as you can see. So forget the 2 and 20 combination, all right? So that's not going to work at all, okay? Is there anything else? How about 10 and 4? Okay, let's try 10 and 4. Well, 10 and 4, again, that can give me negative 40 if I make one of them negative, right? But again, if I play with the signs, there's no way I can get 13 out of that, out of 10 and 4, in terms of adding the two numbers. If I make 10 negative, then that gives me, what, negative 6. If I make 4 negative, that gives me positive 6. Again, no way I can get 13 out of it. So that combination is no good either. Okay, so let's see here. 1 and 40 doesn't work, 2 and 20 doesn't work, 10 and 4 doesn't work, 5 and 8 doesn't work. Okay, so have I exhausted my possibilities in terms of the integers? Yes, I have. That's right. Yes, I have. So there are no more possibilities. So I cannot find two numbers in this case that will satisfy this criteria. And in that situation, if we cannot find two numbers that will satisfy this criteria, then this trinomial here is what? Is not factorable. Conclusion. It cannot be factored. In other words, we cannot write it as a product in this case, okay? So our solution is not factorable. But again, be careful when you make this conclusion, because we have to, what? Exhaust all your possibilities first. So yes, I tried out 5 and 8 probably comes the closest, and 5 and 8 can be added to 13 here. But again, I cannot get the signs to match with negative 40 in terms of the product. So therefore, it doesn't work out, as you can see, right? Negative 5 plus 8 does not give me 13, but negative 5 times 8 does give me negative 40. Okay, so again, look for the combinations that satisfy the multiplication first before you work on the addition. But again, we couldn't find any two possibilities that work out. So therefore, this trinomial here is not factorable. So that's our conclusion. All right? All right, so again, be careful before you make this conclusion. Exhaust your possibilities first. Okay? Let's try another one here. Let's extend this concept of factoring these types of trinomial. Let's try this one. Let's factor 3x squared minus 6x minus 72. All right? And so you may, given this problem, you may wonder, well, wait a minute. This is not of the type x squared plus bx plus c I wrote down earlier, right, in this section, right? Well, yes, right now it's not. But look at these three terms here, right? What do they have in common? Well, look, they do have something in common. There is a GCF here. Can we see that? So my point is, when you're factoring these kinds of problems, when you're factoring any polynomial, the first thing you need to look for is what? The GCF. Now, and up here, I didn't have the GCF for x squared, 13x, and negative 40. There wasn't one other than the number 1. So, but in this case, there is, right? There's what? 3x squared, 6x, and 72. I can take out a what? I can take out a 3 here, right? Can we see that? They have 3 in common here. Can we see that? So let me first factor out the GCF. So again, before we use this technique of factoring here for this section, we should take out the GCF here from the last section. Okay? So 3 times what? X squared, all right? Minus what? 3 times what will give me 6x? Well, 2x, all right? 3 times what gives me 72? We'll just punch down to the calculator. You're going to get what? 24 out of that, so minus 24. Okay, 72 divided by 3, 24, okay? Well, look at this now. So after I take a 3 out, I get x squared minus 2x minus 24. And this is of this type. Can we see that? What's my b? Negative 2. What's my c? Negative 24. So this is of this type in this section. So I can further factor this into 2 binomials. X and x for what? For x squared, as you can see. Okay, now let's figure out the combinations, all right? So let me write down the criteria since I ran out of space here. So let me separate these two parts here, okay? So what do I need? I need 2 numbers that multiply to the last number, that multiply to not the negative 72 because I took out the 3, remember that? So to what? To negative 24. Okay, to negative 24, and add to what? Again, not the negative 6, because again I took the 3 out, so add to what? Negative 2. Okay? So what 2 numbers will fit the bill? Well, after thinking about it a little bit, you're going to see that the number 6 and 4 is going to work out. Okay, 6 and 4 is going to work out. 6 and 4, I can get negative 2 out of that, and also 24 out of that. Now, how can I make that work? Well, I want negative 24, so one of them has to be negative, but which one? Because they have to add up to negative 2. So it's going to be negative 6. Can we see that? So negative 6 times 4, negative 24. Negative 6 plus 4, negative 2. Can we see that? So that's going to work. So my solution will be x minus 6, right, for the minus 6 here, and x what? Plus 4. So there's my solution. Okay, so again, take out the GCF first. Let's try another one. Let me go and clear out the screen. This is a fairly short section here, so let's go ahead and try this one here. Let's look at 5x squared minus 10xy minus 15y squared. Okay, let's go ahead and try this one. Again, take out the GCF here. What is the GCF? 5, 10, and 15. Well, 5 is, right? Can we see that, right? And nothing else, right? Just the 5. Okay, so let's take out the 5 here, all right? So make sure we see that. GCF is 5 here on these 3 terms. So what's left? X squared. 5 times x squared is 5x squared. What else? Minus 2xy. 5 times that is 10xy. And what else? Minus 3y squared, because 5 times 3y squared is 15y squared. Okay, can we see that? So now this is of that type now. Okay, so I need 2 numbers. Oops, sorry about that. I need 2 numbers that multiply to what? To negative 3, the last number here. Okay, put that on the edge here. All right, and add to the middle number, negative 2. Okay? So what'll work? What multiplies negative 3 and adds to negative 2? Well, 3 and 1 are my only choice. Only choices that multiply to 3. Can we see that in terms of the integers? So how can I get this to add to negative 2? Well, if I make the 3 to negative, then it'll work out. Negative 3 times 1, negative 3. Negative 3 plus 1, negative 2. Can we see that? All right, then. So let's go ahead and write down the answer. Now, there's a y squared here at the end, so I need to make an adjustment here, right? So let's do that. So it's going to be 5 times, again, 2 sets of parentheses here, because I have the trinomial of the type we're talking about here in this section, all right? X times x will give me x squared, right? Now, I also need a y here at the end, because y times y will give me what? Y squared here, right? So I need that as well. And look, minus 3 plus 1. So minus 3y plus 1y. I'm going to leave off the 1 right here, right? Invisible 1, right? So final answer is 5 times the quantity x minus 3y times x plus y. Now, again, the order of this doesn't matter. Let's say I have 1 and then negative 3. That's the same thing, right? So in that case, we would write 5 times x plus y, right, for the 1 here, times x minus 3y. But again, the order doesn't matter. Remember, for multiplication, the order in which you write these three different factors do not matter. But the three different factors here have to be the same. And they are, I have the 5 here, check. I have the x minus 3y here, check. I have the x plus y here, check. Again, these two answers are exactly the same, just written in a different order, but that's okay. Let's take a look at a more challenging trinomial to factor. On factoring a trinomial of this type, factoring ax squared plus bx plus c. All right. Back in A2, we factored what? We factored x squared plus bx plus c, where the coefficient of x squared was always 1. Now, that can be a different number now. For example, 5 or 10, for example, right? So that makes this a little more challenging because I need to account for the a as well in the factoring, all right? So there's a couple of techniques that we can use to do this there, and we'll use both techniques to introduce that to you, all right? The first technique I'll use is the AC method. Okay, we'll talk more about that in a moment, all right? And the second technique that we'll use is trial and error. This is where you sort of have to do it in your head. Students typically have the most trouble with this technique, but however, once you get used to this technique, it does happen very quickly, because if you can perform the mental arithmetic in your head, then things work out quite nicely. All right, trial and error and AC method. All right, let's talk about the AC method first. All right, but first of all, what is a trinomial of this type, though? Well, let's consider its problem. All right, let's factor 2x squared plus 13x plus 15. All right. So let's recognize what A, B, and C are. All right. So clearly we see A is what? A is 2. B is what? 13. C is what? 15. All right. So this is of this type, this trinomial. All right. And this trinomial is going to factor into two binomials. All right. But before I get into that, though, let's look at the AC method. All right. AC method means what? AC means A times C, right? That means you take the first number, which is A, you multiply it to the last number, which is C. So we're going to take 2 times what? Times 15. So the AC here is going to be 2 times 15, right? Positive 2, positive 15, which is equal to what? 30, all right? So we multiply the two numbers AC, first number times last number, excuse me, to get 30 here, all right? Let's set up the criteria then, all right? So here's the criteria. We need here, again, I'm looking for those two mystery numbers, right? I need two numbers, okay, so this is how the AC method works. You first multiply the first number to the last number, then you set up your criteria as follows. You need two numbers that multiply to this product AC to 30, all right, and add to, what do you think? Well, the other number here is what? 13, the middle number. So add to the middle number, 13, all right? So this is very similar to the last section where we multiply to the last number and add to the middle, except now, before I do that, though, I need to take the first number times the last number. That's my A times C in this case. That's why it's called the AC method, all right? which gives me 30 in this case, 2 times 15. And then my criteria is I need two numbers that multiply to that and add to what? The middle number, which is 13, all right? So let's think about two numbers that will make this work. Well, after giving this some thought, I hope you got the numbers to be what? 10 and 3, or 3 and 10. Again, the order doesn't matter, right? Because 10 times 3 is what? 30, check. 10 plus 3, 13, check. All right, so these are two numbers we need. Now, does that mean I have to answer immediately? Well, not quite. All right, here's how the AC method works. The AC method is actually lumped together with the technique that we introduced to you earlier called factor by grouping, right? Remember that? We use factor by grouping to factor out polynomials of 4 terms. Here I only have 3 terms, right? So how do I make factor by grouping work with only 3 terms? Well, that's where these two numbers come into play. 10 and 3, they add up to 13, right? So what that means is, with this technique, we're going to break up this 13x into 10 plus 3. So here's what I mean by that. So instead of writing 2x squared plus 13x plus 15, let me rewrite this problem, this trinomial, if you will, as 2x squared, all right, plus 10x plus 3x plus 15. Can we see that? Because 10x plus 3x is 13x, so I'm not changing the problem, right? But I'm just breaking up the middle term into two terms here, so that I have 1, 2, 3, 4 terms here. And when we have 4 terms, how do we factor it? We factor it by what? Factor by grouping. Okay? So what this means is what? We first multiply the first number to the last number to get 30 here. Then I need 2 numbers that multiply to this product and add to this middle number here. And I found those 2 numbers to be 10 and 3. Then I use the 10 and 3 to break up the middle term, to break up the x term, that is, into 10x plus 3x, because that is 13x. Now I have 4 terms. I can do factor by grouping. And recall how I can do that. I group the first 2 terms together and the next 2 terms together. Correct? What is the GCF in the first group? Well, 2x in common. So 2x times what? X plus what? 5. All right? What's in common here? 3. So plus 3 times x plus 5 again. Can we see that? 3 times x is 3x, 3 times 5, 15. Check. All right? So look, I have x plus 5 in common here in the 2 groups, right? So therefore, my final answer will be x plus 5 times 2x plus 3. Okay, can we see that? There's my solution. All right? So I factor this trinomial, which is a little more challenging than the last section, right, into x plus 5 times 2x plus 3. All right? Now, let's solve this problem again with what? With a technique called trial and error. All right? Let's look at trial and error here, okay? So let me write this problem again, but let me clear out the screen here, okay? So this is the AC method, all right? So take your pick. Well, actually, I want you to practice with both techniques on the homework, all right? So let me do the same problem by trial and error. Let me clear this out. Again, keep in mind the answer here. Okay, so let's look at the problem again. So 2x squared plus 13x plus 15, all right? Remember, I put the answer up here we got earlier. It was x plus 5 times 2x plus 3. We got this answer earlier, right? Again, you can check your answer here. X times 2x is what? 2x squared, check. 5 times 3, 15, check. Let's check the middle term. 5x times 5 times 2x here is what? 10x. That gives me 10x. That gives me what? 3x. So 10x and 3x is what? 13x, which is what I want. Right? So this trinomial of this type factors into these 2 binomials here. Right? So with trial and error, then, you want to start off with 2 binomials. So let's start off by putting 2 sets of parentheses. All right? All right? 2 binomials. All right? Now, imagine using the FOIL method but going backwards. All right? So here's the first term here. Here's the first term here. This times what will give me 2x squared? Which 2 here will give me 2x squared? Well, how about 2x and x? Can we see that? All right. 2x times x will give me 2x squared. Can we see that? All right. Well, let's look at these last terms here. All right. What will give me the 15? Well, how about 3 and 5? All right. 3 times 5 is 15, right? So I put a 3 here and a 5 here. Okay. So imagine the FOIL method, working in your head, right? 2x times x, 2x squared. I'm good on that. 3 times 5, 15. I'm good on that. Now I still have to check this middle term, 13x. All right, how do I check that? Well, here's how I check that. The inner and the outer, right? For FOIL method, right? Remember that? So here's my inner, 3x. 3 times x, right? That's 3x. All right? How about the outer? All right? 2x times 5. That's going to be what? 10x. All right? Can we see that? So, therefore, I have 10x here and 3x here. Will that give me 13x? Yes, it will. So, therefore, And what I want positive 10x and positive 3x. We have to play with the signs later on in a different problem. We'll do some examples on that, all right? But in this case, everything's positive, so we're good. So therefore, the answer is 2x plus 3 times what? X plus 5. So therefore, everything works out nicely. Again, this is trial and error. You just do it in your head here, okay? Let's try another one. Let's look at another problem here. let's look at 3x squared plus x minus 10. Okay, let's try this one. All right. Again, I'll use the AC method first, and then I'll use trial and error. Okay. So let's use the AC method here. All right. So take the first number times the last number. All right. So that's going to be what? So we're going to take 3 times positive 3 times what? Negative 10. All right. That gives me what? That gives me negative 30 this time. All right. So what do I need? I need two numbers. Write the criteria down. Again, replay the last example if you need to in this lecture video. Need two numbers. All right. That multiply to what? Multiply here. Sorry about that. That multiply to this product here, right? Negative 30. Okay. Sketchpad's giving me some trouble here. Bear with me. And add to what? Add to the middle number. What's the middle number? Well, invisible 1, right? Positive 1. Add to positive 1. Okay? So what two numbers will multiply to negative 30 and add to positive 1? Well, how about 6 and 5? 6 and 5 will work, right? 6 times 5 is 30. 6 and 5, I can get it to be 1 here. Well, how can I get it to be 1? Well, I need 5 to be what? To be negative, all right? Because then 6 times negative 5 is what? Negative 30, check. And then 6 plus negative 5 is what? Positive 1, check. So again, these two numbers will fit the bill. So again, what I do with these two numbers, I use them to break up this x term, break up the middle term, the middle term here. So let me write this problem then as 3x squared plus 6x. All right, minus 5x, all right, again, 6 and negative 5 are my two numbers here, right, minus 10. Can we see that? All right, again, if I combine like terms, I get positive 1x, so I'm not changing the problem here. But now, again, I have 4 terms. I can use factor by grouping. First 2 terms as a group, next 2 terms as a group. So first group here, I can take out a what? I can take out a 3x here, 3x in common, so I have x plus what? 2 left over. Can we see that? 3x times x, 3x squared, 3x times 2, 6x. Check. Again, the third term is negative for factor by grouping, so take out a negative here. Take out a negative what in particular? How about negative 5? Take out a minus 5. So what I have left, I have x. Now be careful with the sign now, right? Is it minus or plus? Well, let's see. Negative 5 times what will give me negative 10 times positive 2. Can we see that? Again, check your factoring by multiplying back out. When the signs are negative, it is a little bit more challenging, all right? So negative 5 times x, negative 5x, negative 5 times 2, positive 2 that is, negative 10. Check, all right? So again, I have my common factor here of x plus 2. So therefore, I have x plus 2 times what? 3x minus 5 as my solution here. So we have the solution x plus 2 times 3x minus 5, all right? Now let's do it by trial and error. Let me fit it in up here if you don't mind, so I can put them both on the same screen here, if you will. Okay, so let me separate the two problems here. Previous problem. Okay, there it is. Okay, so sorry about that. Okay, so let me do the same problem here by trial and error. So let me write it down again. 3x squared plus x minus 10. All right. So I make 2 sets of parentheses here. Right, imagine the FOIL method. Which 2 terms will give me 3x squared? Well, how about 3x multiplied to x? That will give me 3x squared, wouldn't it? All right. Now, how about 10? Well, how about then 10, I'm thinking of 2 and 5, all right? So how about 2 here and a 5 here, okay? So again, trial and error means you have to do some mental arithmetic here in your head, all right? So what happens if I put 2 here and a 5 in? That'll give me 10, right? Now I've got to play with the signs here. But before you play with the signs, look at the combinations here, all right? So if I put 2 here and a 5 here, that'll give me 10, so I'm good on that. But let's look at the middle term here. The middle term here gives me what? The inner term gives me what? 2x, all right? The outer terms, FOIL method, right? Inner and outer here, right? because eventually we have to make these multiplications when we FOIL things out, when we use the distributive property to multiply things out, right? So 3x times 5 is what? 15x. Okay, 15x here. All right? Now, look at 2x and 15x. No matter how I play with the signs to add them together, there's no way I can get positive 1 out of that. Can we see that? So therefore, this combination I have here isn't going to work. But notice putting 2 here and 5 here isn't going to work. Of course, you know the answer down here anyways, right? But again, that combination isn't going to work because there's no way I can get 2x and 15x. I can turn it into a 1x somehow by adding them. Okay, so that's not going to work. So I need to scratch this, all right? We'll try it again. We're going to switch the 5 and 2 this time. So 3x and x. Trial and error works very well when the first when this number right here, when the first number, when the a that is a prime number, because the only choice is what, 3 and 1 in this case, 3x and x. What if this was a 20x squared? Then it becomes much more complicated because now I can have what? I can have 20x and 1x. I can have 10x and 2x. I can have 4x and 5x. Right? So that gets more complicated if this number here is a composite number. Here it's a prime number, so trial and error is the way to go, I think. It's easier than it's quicker than the AC method, which is what we did down here. All right. So again, I mentioned switching the 2 and 5, right? So we put 5 here and a 2 here this time. All right. Again, let's check the middle term. Okay, let me cross this out. Let's check the middle term here. So the inner is going to be 5x this time. All right. The outer, right? The outer right here, that is 3x and what? 2 will be what? 6x. All right. 5x and 6x. Can I play with the signs to get it to be what? To be positive 1x. Again, I need these two to add up to positive 1x, right? And the answer is yes, I can. If I make the 5x negative here, then and I add them up, I do get 1x. I do get 1x. So I'm good on that. So therefore, I need to make the 5x negative. Okay, so I need to get this to be a negative 5x and a positive 6x. How can I make this happen in terms of my FOIL here? Well, let's see. Where's my 5x term? Well, here it is, right? Here's the 5x term. Can we see that? 5 times x is 5x. I need that to be negative. So let's make this negative. Now that gives me negative 5x. Can we see that? All right. Now I need the 6x to be positive. So where's my 6x? Here it is, right here. All right. 3x times 2 is what? 6x right here. So therefore, let's make that positive. So there's my solution. 3x minus 5 times x plus 2, which is the same answer we got down here. So again, trial and error and AC method. Take your pick, but I want you to practice with both techniques on the homework. Let's try another one. All right, let's look at something like this. Let's look at 9x squared. All right, let's make it y. We've been dealing with x. Let's use y instead. 9y squared plus 3y plus 2. Well, let's go and factor this one here. 9y squared plus 3y plus 2. All right, so let's go ahead and break this up into, well, actually, again, let me do AC method first instead of trial and error. Okay, so let me take 9 times 2 here. Okay, so let's use AC method first. All right, 9 times 2. Okay, so that's gonna be what? 18. Again, I like trial and error though. Okay, if I were doing it personally, I would use trial and error because it's faster. I can do the math in my head. The mental arithmetic in my head. But again, that does take some practice, but once you get used to it, it happens very quickly. So trial and error is faster than the AC method. That's why I like it a bit more. Okay, so A times C, right? 9 times 2 is going to be 18. So I need two numbers, all right, that multiply to that product, 18, and add to what? Add to the middle number, positive 3. Can we see that? All right. So, excuse me. So let's see. What two numbers will fit the bill here? What two numbers will work here for us? Let's see. What two numbers will work? So let's see what two numbers will work here. Sorry, having trouble with my sketch pad there. So sorry about that. Okay. So these two numbers are multiplied to 18 and add to 3 here. So what two numbers will work? Well, how about 6 and 3? All right, 6 and 3. That multiplies to 18. But again, that is not going to add to what? Positive 3. Now you may say, well, wait a minute though. What if I do this? What if I make the 3 negative? 6 and negative 3. Now it does add to positive 3, doesn't it? 6 plus negative 3, isn't that positive 3? Well, yeah, that's true, but again, 6 times negative 3, though, is going to be what? Negative 18, but I don't want that. I want positive 18, right? So again, you try to satisfy the multiplication criteria first before you satisfy the addition criteria. So again, don't jump the gun and say 6 negative 3 because that does not multiply to 18, positive 18 that is, all right? So therefore this is not going to work. And 6 and 3 again, that does multiply 18, but it does not add to 3, so that's not going to work. How about 2 and 9? Again, think of the combination. Don't worry about the signs. We can always play with the signs. But look at the combinations first, right? 2 and 9. Any way to get 3 out of that? No. No good. All right? 1 and 18. Any way to get 3 out of that? No. Okay, so again, think about the combinations first. There's no way we can add 2 and to play with the signs of 2 and 9 to get positive 3. No way I can play with the signs of 1 and 18 to get positive 3 again. So therefore, none of these combinations will suffice. So therefore, we cannot find such two numbers that satisfy this criteria. So what's our conclusion again? Well, if you remember from the last section, it will be what? Not factorable. Okay? So these trinomials are not always factorable, right? If we exhaust our combinations and we find out that, okay, look, none of this is going to work out. I cannot satisfy this criteria with the integers I'm given here. So therefore, the entire polynomial, the trinomial here is not factorable. Okay? Again, not factorable. Okay, so again, be careful, and you'll figure that out as well when you try the trial and error method. For example, 9y squared plus 3y plus 2. If I try it by trial and error, okay, so 9y squared, I'll try 3y and 3y to give me what? To give me 9y squared, right? And 2, my only combination is 2 and 1. So 2 here and 1 here. So that'll give me what? That'll give me 6y, that'll give me 3y, 6y and 3y. Again, I need them to be positive here, so therefore I cannot get a 3 out of that. So let me switch it then. Okay, let me switch that. 1 here and 2 here. Okay, 3y and 6y, again, they both have to be positive because of this positive 2 here. Or both negative, but again, that isn't going to work as well because if they're both negatives, yes, it multiplies to positive 2, but if it was negative 1, for example, and negative 2, then what happens? We get negative 3y and negative 6y. That's negative 9y. That's not going to give me positive 3y. So again, that combination doesn't work either. Now, we'll try a different combination then, okay? So let me try this. Instead of 3y and 3y, let me change it to 9y and y. Okay, how's that? Well, let's try 2 and 1 once again. So 9y squared, we're good on 9y squared. How about 2 and 1? Again, that's 2 and 9, right? 2y and 9y. No way I can get what? I can get 3y out of that, okay? Even if I switch it around, 1 here and 2 here. So again, I get what? 1y here in the middle, and 18y out here, right? 9y times 2, 18y. 18 and 1 again, not going to work. I cannot get 3y in the middle from this combination. So therefore, again, I've exhausted my combinations. So therefore, again, this is not factorable. Okay, so conclusion, same thing, right? Not factorable. Okay, so again, be careful with some of these trinomials, right? They may not be factorable, but you need to exhaust your possibilities before you make that conclusion. And maybe the AC method is better at making such a conclusion here. All right, let's go ahead and try another problem. Let me go and clear up the screen. Let's try this one here. Let's go ahead and try another problem. Let's go ahead and clear out the screen right here. Okay, so let's look at 15x squared. Right, 15x squared minus 43x plus 22. Okay, a little more challenging now. The numbers are bigger now, right? So see if this is factorable or not. Let's check that out. All right, so let me use the AC method once again. All right, so 15 times 22 here. So let me take the 15, multiply it by 22 on my calculator. All right. Positive 15 times positive 22, so that'll give me what? That'll give me positive 330 on the calculator. All right, just punch in the calculator. All right? Okay, then. So what's the criteria then? I need two numbers. All right, need two numbers that multiply to 330. All right, this product right here, this AC here, and add to what? The middle number. Add to negative 43. All right, so you have to do some research here, right? Challenging problem here, right? So What two numbers will multiply to 330 positive and add to 43 negative? Well, let's see. Well, after thinking about a little bit, I hope you came up with the two numbers hope you see at least as the two numbers as negative 10 and negative 33. All right? So this is factorable. I do have such two numbers, as you can see, right? Negative 10 times negative 33, positive 330. I'm good on that. Negative 10 plus negative 33, negative 43. Check. All right? So I do have that. So now I can break up the middle term. So this becomes 15x squared minus 10x minus 33x. Again, that is my negative 43x here, right? Plus 22. Okay? Grouping. So first two terms, next two terms, factor by grouping. So what comes out here? 5x. 5x comes out, so I have 3x minus 2. So make sure we're sharp on factor by grouping. I'm not going to spend too much more time on that. All right? The third term is negative, so let me take out negative. 33 and 22, negative 11. So negative 11 here. So I have 3x minus 2 again, because negative 11 times negative 2 is what? Positive 22. Okay? So make sure we see that. So there's our solution, right? 3x, so there's 3x minus 2 in common here in the two groups. So we get 3x minus 2 times 5x minus 11. Okay? So that's our solution here with using the AC method. All right? Trial and error. Let's use trial and error real quickly here. All right, trial and error. So trial and error again. Let me break this up into two sets of parentheses. Let me copy the problem again. 15x squared minus 43x plus 22. So let's break it up. All right, so 15x squared, let me start with 5x and 3x. Again, I could have started with 15x and 1x, right? But try to start with two numbers that are closer together. In this case, 5 and 3 is closer together than 15 and 1, right? So let me start with we have two numbers that are closer together that multiply to 15. So 5 and 3 will fit the bill. So 5x times 3x is going to be what? 15x squared, right? Okay, then how about 22? Well, 2 and 11, right? 2 and 11. So suppose so let me put 2 here and 11 here, all right? 2 here and 11 here, all right? So let's look at the combinations again. That gives me 6x, all right? And that gives me what? 55x. That gives me 55x, okay? So 6x here, 55x here. Well, again, 55 and 6, there's no way I can get 43 out of that. So that's not going to work. All right, let me try a different combination. 5x and 3x once again for 15x squared, all right? This time, let me switch the 2 and 11 around. Let me put 11 here and 2 here this time, all right? So now I have here, the middle term here is going to be what? 33x, all right? And up here is going to be what? 5x times 2 is going to be what? 10x, all right? So I have here 10x and 33x. 10 and 33, can I get 43 out of that? Yes, I can. I can make that happen if they're both negative. Negative 10x plus negative 33x is negative 43x. Check. All right? So how do I make that happen? Well, I need the 10x to be negative. So where's my 10x? Well, here it is. 5x times what? Times 2 right here. Right? There's my 10x. Can we see that? So let's make that negative 10x. All right? Where's my 33x? Right here. 11 times 3x. That's 33x, right? I need that to be negative. So make that negative here. So therefore, I have 5x minus 11 times 3x minus 2, which is the same answer we got here by trial and error. Again, I like trial and error more because it happens very quickly once you get used to it, but you do have to think through some of the combinations of numbers, right? Look, first of all, so my hint for trial and error is what? First, get the combinations that work. Don't worry about the signs of the numbers, right? For example, start with 10 and 33, right? In other words, start with 11 and 2, and then I get the 10 and 33 combination, right? So can I get 43 out of that if I play with the signs? Yes, I can. So therefore, then this is the right combination. I just have to make the signs correct to make this work. Okay? So there's my solution there. All right? Let's try another one here. Let me go and clear out the screen. All right? Let me do one by trial and error here, if you will. Okay? So let me go ahead and show you this example right here. Okay? Let's look at 10x cubed this time, all right, plus 12x squared plus 2x. All right? Well, again, this is not up the form we're talking about in this section, isn't it? Because I have x cubed, right? Not x squared, right? So, but look what happened here. 10x cubed, 12x squared, 2x. Isn't there a GCF to take out? Once again, the very first thing we do when it comes to factoring is what? Taking out the GCF. So, therefore, my GCF here is going to be what? 2x. Can we see that? All three terms here have 2x in common. So let's take out a 2x first. So again, first rule of factoring is what? Take out the GCF. So what's left? 5x squared, all right, for the 10x cubed here. And what else? Plus what? 6x, right? 2x times 6x is 12x squared. And then 2x times what is itself? 2x times 1. Okay? Now, look at this. Now this is in the format that we're talking about in this section. So let me do this by trial and error. Okay? So trial and error, all right? Here's how this works. So this is easier to do by trial and error because 5 here is a prime number. And look, 1 is a prime number, right? That makes it real simple. So 5x and what? X. That's the only combination, 5 and 1, right? For 5x squared. And here, my only choice is what? 1 and 1. And let's check the middle term for 6x. Well, let's see. This gives me the 1x, and that gives me the what? The 5x. All right? So I have 5x here and 1x here. So 5x and 1x. That's going to be what? 6x. Positive. They're both positive, right? So therefore, we have our solution. Okay, so 2x times 5x plus 1 times x plus 1 is our solution right here. These three factors. All right? So again, the key is what? Take out the GCF first, though, for any factoring problem. All right? Let's look at this one here. Let's look at one more by trial and error. Let's look at, for example, let's try this one here. 7x squared plus 47x minus 14. Okay, let me do some problems by trial and error since that's my favorite technique here. All right? Now, in this case, is there a GCF to take out? No, there is not in this case, right? No, there is not. All right? So let me begin the trial and error factoring here. Now you can see if I use the AC method, 7 times negative 14, that's going to be a big number. And then I need to add up to 47 in the middle. That might be a little more challenging for us to find the combinations. But we take our time, we can still find it. But let's use what? Trial and error again. Again, if the first number is prime, it makes it nice to use trial and error. Because 7x squared, the only combination is 7x and what? And x, right? There's no other possibilities here, okay? So how about 14? Well, I'm thinking of 2 and 7, all right? 2 and 7 is 14, all right? So let me put a 2 here and a 7 here, all right? Can we see that? 2 here and a 7 here. Trial and error. We have 7x and x will give me 7x squared, so I'm good on that. 2 times 7 is 14. I'm good on that. Okay, don't worry about the signs. We're going to fill that in right now. So let's check the middle term. So that gives me what? That gives me the 2x here. Okay, this inner multiplication. How about this outer multiplication? That gives me what? 7x times 7 is what? 7x times 7. That's 49x. Can we see that? All right. So 2x and 49x. With 2 and 49, can I get a 47 out of that? Yes, I can. I can get positive 47 out of it if the 2x is what? Negative. Now that does give me positive 47x, which is what I want. Okay. So again, we look for the right combinations first before we play with the signs, all right, in trial and error, all right? So how does this work then? Well, I want to get negative 2x now, right? So where's my 2x? There it is, right? Here's the 2x term. I want that to be negative, so minus, all right? I want the 49x to be positive, right? So therefore, here's my 49x, so therefore it's going to be positive. So my solution is what? 7x minus 2 times x plus 7. Again, trial and error happens very quickly once you get used to it, though. Okay? Let's try another one. Let's look at this one. Let's look at 21 minus 20x minus x squared. Okay? Well, look at this. The x squared term is written at the end this time. That's okay. We can still work it out by trial and error this way. Okay? So let me set it up. So get 2 parentheses here. This time, I want the first terms to multiply not to the x squared here at the end. I want it to multiply to what? To 21 here, all right? So I'm thinking of what? Well, 21, let's try 7 and 3. Can we see that? 7 times 3 is 21, correct? So we're good on that, All right, so 7 times 3 is 21, so we're good on that. And last term is x squared, so my only choice there is just x and x here to give me what? The x squared at the end, all right? Let's check the middle term here. So that gives me what? That gives me 3x there, okay? Can we see that? And 7 times x right here gives me 7x. All right? 3x and 7x, right? Can I get 20x out of that? No. There's no way I can play with these signs, add them or subtract them to get 20x, right? So this combination here is not going to work. So this is not going to work. Okay? Let's try it again. All right? So instead of 7 and 3, let me try what? 21 and 1 for 21 right here, right? For 21. So let's try 21 and 1. All right? 21 times 1 is what? 21. So I'm good on that. Again, x squared at the end, so just x and x. All right? No other possibilities there. Now let's check the middle term. So this gives me 1x once again. The middle term here, 1x. How about 21 times x? That gives me 21x. 1 and 21. Can I get a negative 20 out of that? Yes, I can. I can get negative 20 out of this, couldn't I? To get negative 20 out of this, I need 1 to be positive and 21 to be what? Negative. Because that will give me negative 20x, which is what I want. Okay? So I want f1x. I want the 1x to be positive, right? So here's my 1x right here, right? That'll be what? Positive. Here's my 21x right here. Can we see that? That should be what? Negative, right? So minus. So my solution here is going to be 21 plus x times 1 minus x. Okay? So we're saying that's our solution down here. Right? 21 plus x, 1 minus x. All right? Can we see that? Can we see that? Excuse me. Trial and error, all right? So again, practice this technique. I like this technique more than AC method because it's efficient. It just takes a few mental arithmetic steps to figure it out. Okay, but it does take some practice though. Okay, let's do one more here, and then I'll use some problems to post in Blackboard. Let me clear this out. And let's do one more here. Let's try this one. Let's look at 12x cubed y. All right, plus x squared y. All right, minus 6xy. Let's try that one. All right. Now again, this is not in the form we're talking about in this section, but look at these three terms. There's a what? There's a GCF to take out, as you can see, right? What is the GCF of these three terms? Well, hopefully you see for the numbers 12, 1, and 6, so I can't do anything with the numbers, right? But how about x cubed, x squared, and x? Remember, lowest power wins, right? So it will be x coming out, y, and y, so y comes out. So xy comes out. So the GCF here is xy. Can we see that? So let's see what's left. So I have 12x what? Squared, because I need 2 more x's to get x cubed, right? My y is covered. Okay? So make sure we review this in 8.1 if we need to, in terms of that section. Xy times what is this? It's going to be this. Well, plus what? I need 1 more x here, because I have x squared. I have 1x here. I need 1 more, and my y is covered. And minus what? Minus 6, since x and y are both covered. Okay? All right. Let me go back to the AC method for this problem here, if you don't mind. Again, I would prefer to do this by trial and error, but for those of you who like the AC method and want to see more of it, let me use the AC method here. I'm not going to do it by trial and error here. Okay? I'll just present it by AC method. All right. So let's take 12. So let's take the first number times the last number. 12 times what? The last number is what? Negative 6. 12 times negative 6, which is what? Negative 70 what? 72. All right. So what's the criteria I need? So again, leave off the xy on the side. Let's focus on this trinomial inside the parentheses. All right. So need what? 2 numbers that multiply to negative 72. That product right there. All right. And add to the middle term, which is what? What's that? Positive what? Positive 1. Okay, positive 1. All right. What 2 numbers will fit the bill? Well, 8 and 9 will work, right? 8 times 9 is 72. Now, I want 8 and 9 to add up to positive 1. That means what? I want 8 to be negative here, right? If 8 is negative, then negative 8 plus 9 will be positive 1. And again, that product will be what? Negative 72. So we're good on that. Okay then, so let's go ahead and break up this. So get focus on this trinomial. Forget about the xy for now. We'll put it back in the final answer. All right. So let's focus on this here. So this is going to be what? 12. Excuse me. 12x squared minus 8x. All right. Plus 9x. Plus 9x minus 6. Okay. Again, I'm just breaking up the x term here, the 1x, right? Isn't that positive 1x right here? Yes, it is, right? So let's do it by grouping now, right? 4 terms here, factor by grouping. First 2 terms, next 2 terms. What's the GCF here? Well, 4x. So take out a 4x, if you will. So I have what? 4x times what is 12x squared? That'll be what? 3x minus 2. Okay, can we see that? 4x times 3x minus 2 will give me 12x squared minus 8x, all right? How about 9x and minus 6? Well, 9 and 6, that's 3, right? So, and it's positive in the third term, so let's take out a positive 3 here. So I have 3x, right? 3 times 3x is 9x, and then 3 times what is negative 6? Minus 2. Okay? So we get our factors here in terms of factor by grouping. All right? So what do we have then? We have 3x minus 2 in common, so therefore we get what? 3x minus 2 times what? So take out 3x minus 2 times what? 4x plus 3. 4x plus 3. But again, that's not the final answer because we took out the what? The xy in the beginning, so I need to put that back in. So my final answer will be written as xy times 3x minus 2 times what? 4x plus 3. Okay, so that's the solution we're looking for this problem here. Again, always look to take out the GCF whenever you can. In this case, I could have factored this by trial and error, but I used the AC method, as you can see the work here. All right, so replay this video if you need to. Okay, so let me go and give you some problems to try on the homework. I'm sorry, not on the homework, but on Blackboard. I post the solutions to these problems in the discussion area on Blackboard. Let me clear this. Okay, so let's go and post the answers to these questions. So let's factor the following. Let's go ahead and factor 2x squared minus 17x minus 17x, all right, plus 21. So factor that, post the answers in the discussion area on Blackboard. All right, number 2, let's go ahead and try 6a squared plus 23a, all right, plus 21. Okay, again, post the answers to that in the discussion area in Blackboard. And finally, for the last one, I want you to look at this one here, 15x cubed, all right, plus 40x squared, okay, minus 80x. 80. Okay, sorry about that. So 15x cubed plus 40x squared minus 80x. Factor that. There's a GCF involved in this problem, as you can see, right? And then again, post the answers to these 3 questions in the discussion area in Blackboard. Then, okay, we'll answer any homework questions you have in class. Okay, so until next time then.